Hi dear students, in this presentation we will be discussing about wind energy, and before moving to the topic of wind energy we must have a basic idea about what is wind and various sources of wind. So first definition of wind is actually wind is atmospheric air in motion caused by difference in atmospheric pressure. See, actually air is a fluid, we can consider air as a fluid, so always the fluid will move from higher pressure region to lower pressure region. So if there is a low pressure region, the air actually from the high pressure region will automatically move towards that low pressure region. So that movement of air is actually known as wind. Okay, when a difference in atmospheric pressure exists, air moves from higher to the lower pressure area, results in winds of various speeds. See how much pressure difference is there. Correspondingly we will have the velocity of wind more. Okay, it have two different origins. They are planetary winds as well as the local winds. So that are the two different types of wind we can say. Planetary winds are caused by solar heating of earth's surface near the equator than near north or south pole. See, the north the equator of the earth is always facing the sun, so the more thermal energy is received by the equator than north and south pole. That already we are knowing. The temperature at the north and south pole is very less, or low temperature it is there in now north and south pole, and the even ice glaciers are there in that north and south poles. The reason is the temperature is very low. The reason for that low temperature is the availability of the solar radiation or solar energy is very less in the north and south poles compared to the equator. In the equator region we will have the maximum harvest of the solar energy. So that means the temperature of the air at the equator will be much more higher than, always higher than that of the temperature of the air in north pole or south pole. This causes warm tropical air to rise and flow through the upper atmosphere towards the poles, and cold air from poles will flow back to the equator nearer to earth's surface. So these types of wind are known as planetary winds, and it is continuously blowing. Okay, that is what is known as planetary winds. And the reason for this one is uneven heating of air at the equator than air at the south and north pole than at the equator. Okay, now the same effect can be there in the local areas also. See, that is what is known as local winds. Local winds are caused by unequal heating and cooling of land and water. Usually they are two close bodies. See, land and water are very close bodies. We know that land having a tendency that its temperature will be increasing within a lesser time compared to the water. To increase the temperature by absorbing solar radiation in case of water is actually a slow process, but whereas the land will land will be getting heated very quickly. So and the reverse thing is also there, that the thermal energy storage capacity of the water is much higher, means it will take long time to cool down. That is the reverse thing in case of water, whereas the land will get cool very easily. Okay, so both are there behind the local winds. So local winds are caused by unequal heating and cooling of the land and water, and also by hills and mountain sides. Okay, during the day warm air over land rises upward, and colder air from the lakes, ocean, forest area flows towards the warmer zones. That is what is happening in the daytime. See, the land will absorb more solar radiation and will get heated quickly as compared to the water. So always during daytime the land will have higher temperature compared to the lakes and all, water in the lakes and all. So what happens is always the air above the land will be having higher temperature compared to the temperature of the air over the water bodies. So always there will be a flow of air from um, land towards the sea. Since land is much hotter, the hotter air will rise upward due to the lesser density. So correspondingly higher density air at the sea level will be blowing towards the land also. So in the night this phenomenon will take the reverse step. That means as I have already mentioned, the water is having higher thermal capacity, so it has the tendency to hold the heat energy for a long time. So the cooling of the water will be much will be a slow process, whereas cooling of the land is a faster process. So what happens is, in the night time, the sea or the water body will be having higher temperature compared to the land side. So this local temperature difference is also causing for the formation of the winds. That is what is known as local winds. Anyway, coming to the advantages and disadvantages of the wind energy. First one is advantage. The first point is, it is totally free. Wind blows day and night, which gives wind turbines the ability to produce electricity at all the hours of the day. See, in the case of solar energy, it is available only in the daytime. In night, we cannot produce the power. But in case of wind energy, there is no such restriction. It is available during day and night. So 24-hour power production is possible. Of course, it is basically depending on the wind velocity. So the amount of energy that we can produce will vary. That will come as the disadvantage. Now, second advantage is clean. Wind energy is a renewable source of energy that generates no pollution, unlike fossil fuels such as coal, natural gas. It does not produce atmospheric emissions that cause acid rain or greenhouse gases. That is the another advantage. Now, coming to the third advantage, that is cheaper form of energy. Wind energy is one of the lowest prices renewable energy technologies available today, costing between 4 and 6 cents per kilowatt hour. Only that much. In order to produce 1 kilowatt hour, only 4 to 6 cents, and is actually not in Indian money. So that much low cost only is there for the production of energy, but of course the initial expenditure will be much higher. Okay, but once it is installed, production cost will be very less. Now, next advantage is place ability. Farmers can also still continue to use the land due to the turbine only taking up a fraction of the land. So during the implementation of the wind turbine, it takes only a small land area, so the remaining area can be utilized for the cultivation and all. So place ability is the another advantage. Next advantage is domestic, can be used of small size too, so can place anywhere. See, even small sized wind turbines producing much smaller energy is also available, which is compact also, so we can place it anywhere. If you want to produce the energy in a large quantity, then of course the size will be very large, then the implementation also will be difficult. Now, the last advantage is remote area supply, best for remote area where availability of the wind is high. Of course, in the main majority of the places where the other sources of energy are not available, in that cases wind energy is of course plentifully available. So in the remote area, it is best one for the remote areas. That is the last advantage. Coming to the disadvantages of wind energy, efficiency of a wind turbine depends on the wind speed. So if wind speed is very less, then it is not possible to produce the power. That is the main disadvantage. So it is depending on the wind speed, and of course it is varying also, even from time to time it is varying. So that is the main disadvantage of this one. Even after implementing everything, if the the required wind speed is not available in that area, then there is no use. The next one is noise problem. Some people find it annoying, and if it is close to a house, it may lead to sleeplessness and to anxiety and stress for some individuals, which could lead to health issues. Of course, if the wind turbine is of very large structure producing high energy, then of course it is very noisy, and this will be very much disturbing for the people nearby. Okay. So the next disadvantage is, even though the cost of the wind power has decreased drastically in past 10 years, the technology requires higher initial investment than the fossil fueled generators. See, a lot of development has taken place in this area, but still the initial investment cost is very high. That is the main drawback. Power density is very low. Needs a very large number of windmills to produce a modest amount of power. If you want to produce operate it like a wind power plant, then lot of windmills are required. You might have seen it in a particular area, around 100 to 150 windmills are operating together, then only we can produce the required amount of power if you want to light an entire village or entire city. Okay, so that power density is very low. Okay, now cannot meet large scale and transportation energy needs. That is the another disadvantage. Now coming to the environmental problem, of course Wind turbines kill birds and bats, destruction of native vegetation, erosion problems also will be there with the wind turbines. And fires in wind turbines, while very rare, are extremely difficult to fight. If any short circuit and all happens, then there can be a possibility of fire in the wind turbines. See, the wind turbines which is producing very large amount of power is of massive in structure, very huge in structure. So if any fire or something happens, short circuit happens, then it is very difficult to deal with it. Okay, so that is the environmental problem related to wind energy. Now coming to the principle of wind energy conversion, there are two primary physical principles which energy can be extracted from the wind. These are through the creation of either lift or drag force. So wind turbines are there. Some will be working basically based on the drag force and some basically on the lift force. And of course, most of the modern wind turbines are working as a combination of both lift and drag force, or combination of the two. Okay, so you can see here the figure which will explain what is the lift force. This is the lift force. You can see this is a aerofoil shape. You might have heard about aerofoil shape. Uh, the regarding aerofoil shape, what we have is it will provide a smooth flow over this shape, and there will be less resistance for the flow. You can see some streamlines drawn here. The air will be flowing by two paths. One is through below this aerofoil shape cross section, we can say, and the sometimes the streamlines will be flowing over the aerofoil shape also. So you can see from this figure itself, if the air is flowing through the upper surface of the aerofoil shape, what happens is it has to cover more distance compared to the air which is flowing through the lower part. Okay, so here the air has to traverse more distance, means the velocity of the air at the upper surface should be much higher compared to the velocity of the air which is blowing at the lower part. Here air has to cover only a small distance compared to the upper part. So if we want to cover small distance, then of course velocity will be less. Here the velocity will be more. That means if velocity is more, means actually expansion is taking place. Pressure, with the expense of the pressure only we can increase the velocity. So if velocity is increasing, pressure will be decreasing. So here we will have high pressure, here we will have a low pressure. So that difference in pressure will act as a force. That force is known as lift force, and it is always perpendicular to the flow direction of the air. Okay, so lift force is always perpendicular to the flow direction of the air. So with that lift force, the blade will be rotating continuously. Okay, that is what is the basic principle of lift force. Lift is created by the flow of air over an aerofoil. The shape of an aerofoil causes air to flow faster on the top than on the bottom. See, because of that shape, the air over the aerofoil will have higher velocity than the air at the bottom portion. The fast flowing air decreases the surrounding air pressure. See, only with the expense of the pressure we can increase the velocity. So that's why in the upper region we will have low pressure, because the air pressure is greater below the aerofoil than above, the resulting force is created. So if the pressure difference is there, of course upward force is created. That means the blade will be lifted upward. That's why that name lift. Okay, and the important thing is lift is always perpendicular to the direction of the airflow. Coming to the drag, every physical body that is propelled through the air will experience resistance to the airflow. See, air is blowing in a particular direction. So if it is hitting a particular body, always a resistive force will be exerted by the body on the air, as well as air will be exerting a force on the body also. Because of that force, the body can be moved. That is what is happening in the case of a wind turbine working on the drag force. This resistance is called drag. So drag is you need in the direction of the airflow. Here lift is always perpendicular to the direction of the airflow. Generation of lift always causes a certain amount of drag to be developed. Always along with lift, always there will be drag also, but lift force will be much higher compared to the drag force in the case of aerofoil shapes. When a good aerofoil, with a good aerofoil, the lift produced can be more than 30 times greater than the drag. See that difference? Lift force produced by the aerofoil shape will be around 30 times more than that of the drag force. So that means high energy is able to generate with the with that aerofoil shape, of course, that much energy we can harvest. Okay, so lift devices are more efficient than the drag devices. ജസ്റ്റ് ഡ്രാഗ് എന്ന് പറയുമ്പോൾ നമ്മളിപ്പം എയർ ഒരു ഡയറക്ഷനിലേക്ക് ഫ്ലോ ചെയ്യുന്നതായിരിക്കും, അവിടെ ഒരു റെസിസ്റ്റൻസ് നമ്മളൊരു കപ്പ് ഷേപ്പിലായിട്ടില്ല എന്തെങ്കിലും ഒന്ന് വെച്ചു എന്നിരിക്കുക. അപ്പോൾ സ്വാഭാവികമായിട്ട് എയർ വന്ന് ഈ കപ്പ് അല്ലെങ്കിൽ ഒരു ബ്ലേഡോ ഒന്നും കൊണ്ടുവന്ന് വിചാരിക്കുക, ഒരു കേർവ്ഡ് ആയിട്ടുള്ള ഒരു ഒബ്സ്ട്രക്ട് ചെയ്യുന്ന എയറിൻ്റെ ഫ്ലോനെ ഒബ്സ്ട്രക്ട് ചെയ്യുന്ന രീതിയിൽ എന്തെങ്കിലും വെച്ച് കഴിഞ്ഞാൽ സ്വാഭാവികമായിട്ടും എന്ത് ചെയ്യും, എയർ അതിനെ തള്ളി പുറകോട്ടേക്ക് നിൽക്കും. അതാണ് ഡ്രാഗ് ഫോഴ്സ്. അപ്പോൾ ആ ഫോഴ്സ് എപ്പോഴും എയർ ഏത് ഡയറക്ഷനിൽ ബ്ലോ ചെയ്യുന്നോ അതേ ഡയറക്ഷനിലായിരിക്കും ഡ്രാഗ് ഫോഴ്സ് ഉണ്ടാവുക. ലിഫ്റ്റ് എന്ന് പറയുമ്പോൾ നേരെ തിരിച്ചാണ്. അതിനൊരു എയറോഡൈനാമിക് ഷേപ്പും എയറോഫോയിൽ ഷേപ്പ് വേണം. അപ്പോൾ താഴെ മുകളിൽ പ്രഷർ ഡിഫറൻസ് കൊണ്ട് അപ്വേർഡ് ഡയറക്ഷനിലേക്കായിരിക്കും മൂവ്മെൻറ്റ് ഉണ്ടാവുക. All the wind turbines work on either drag principle or lift principle. So coming to the drag principle, drag devices are simple wind machines that uses flat, curved or cup shaped, unlike aerodynamic shapes of the lift devices, blade to run the rotor. So always drag devices, the shape of the blades or runner will be of curved or cup shaped. Okay. In a drag blade design, the wind pushes the blade out of the way. That is what is only happening. Just wind is pushing the blade out of its way. See, the blade will be coming as an obstruction to the airflow. So because of that obstruction, the air is having high velocity, enough velocity, then what happens is the air will be pushing that blade out of its way. That is what is only happening. The drag powered wind turbines are characterized by slower rotation speeds and high torque capability. So of course the rotational speed of the wind turbines working on drag principle will be very less. Coming to the lift principle, the lift devices employs the same principle that enables the airplanes, kites and birds to fly. The blade is essentially an airfoil or wing. The top surface of the blade airfoil is more curved than the bottom surface. When the air flows past the blade, a wind speed and a pressure difference is created between the upper and lower blade surfaces. That I have already explained what is lift. So based on this, the wind turbines are classified as the wind turbines working on lift force as well as the wind turbines working on drag force also. Okay, so and also based on the axis of the wind turbine, we can classify it as vertical axis wind turbine and horizontal axis wind turbine also. Okay, now coming to the major components and working of the wind turbine, you can see main components here. This is the hub, we call it as a cylindrical part. In that we will be fixing the blades, that is what is rotor, we will call it as rotor. So this is aerodynamic shape blade we can see here. So wind will be blowing in a particular direction. Based on the direction of the wind, again classification is that we will explain in the upcoming slide. Anyway, to the hub we will be connecting the rotor, and the shaft of the rotor is connected to nacelle, we will call it as inside the nacelle. See, this outermost casing is actually called the nacelle, and within that casing we will have transmission system. Every transmission system will be there. Transmission system includes speed increaser, drive shaft, clutch, coupling, etc. Speed increaser means gear arrangement will be there. Now the shaft will be finally connected to the electrical generator. So based on the rotation of the rotor, hub will be rotating. The rotary motion of the hub is actually transmitted to the shaft. The shaft is since connected to this transmission mechanism where its speed is getting increased or decreased, or we need a constant speed. If we need a constant speed, mechanisms are there to control the speed. So based on that speed, the remaining part of the shaft will be rotating at a constant speed, and that constant speed is provided to the electrical generator, which in turn will be producing the electricity. Okay, so everything is at the uppermost portion of the supporting structure or tower, we will call it as. This is a huge massive structure. Actually, supporting structure or tower is a massive structure, even having a weight of around 2 or 3 tons itself. It is having that much weight, that much massive structure it is. So the nacelle is actually placed at a particular height above the ground level, usually 20-30 meters above the ground level. The reason for that is there should not be any obstruction for the flow of the wind. That's why we are keeping it at a very high altitudes. Now the supporting structure will be fixed at the ground level, and the footing or control building, everything, control system, everything will be at the bottom of this massive structure or tower. Okay, now coming to the components of the wind turbine, first one is nacelle. Nacelle is the cover housing that houses all of the generating components in the wind turbine, including the generator, gearbox, drivetrain, and even brake assembly. Everything is included within this case. That is what is known as nacelle. So the outermost casing is commonly known as nacelle, and every transmission mechanisms are included within that one. Now coming to the other component, first one is rotor. Rotor is actually the blades. Blades and hub together is commonly known as rotor. So this hub plus blade, entire hub plus blade is commonly known as the rotor. Um, and it is attached to the slow speed shaft. Blades are manufactured from fiber glass reinforced polyester or steel or aluminum. So FRP is lighter and exerts less stress on bearing and rotor hub. That's why it is commonly used. Now next is hub and shaft. You can see it from here. This is hub, and to the hub the shaft is connected. So based on the rotation of these blades, the hub also will be rotating. That rotary motion is finally transmitted to the shaft. That shaft will be in turn connected to the transmission mechanism. Within that transmission mechanism, we will have the gear arrangements to control the speed. Okay, hub and shaft. The blades are attached to the hub. Hub is the front portion of the shaft which faces the wind direction. Always, hub will be always facing towards the wind direction. So by sensing the direction of the wind, we have to rotate the that nacelle and hub. Some governing mechanisms are there, some controlling mechanisms are there to rotate that entire part, that uppermost part. Okay, so we will make sure that always hub is facing towards the wind. Normally conical shape and other end of the shaft is connected to the transmission system. So front end of the hub is always in conical shape to have lesser resistance. Now next component is Synemometer. The main function of the anemometer is to measure the wind speed, and it is fed to the controller mechanism so as pitch angle and yaw is controlled. Yaw is an important mechanism that we will discuss in the upcoming slide. Okay. Now coming to the next important component, that is transmission system. The transmission system transmits mechanical power generated by the rotor to generator. So that is the function of the transmission system. So the mechanical power is generated at the rotor, so that hub is actually rotating. The function of the transmission system is to transmit that rotary motion mechanical power to the generator at the required speed. It contains gearbox, clutch and braking system. It must be designed for high dynamic torque load due to fluctuating power output from the rotor. See, based on the wind speed, the RPM of or the rotary motion of the hub will be varying. So always fluctuating torque will be acting on this transmission system. So it must be designed for high dynamic torque load due to fluctuating power output. Okay. Now coming to the last component, that is electric generator. Most of the grid that you already know, the function is to produce the electricity. So inside we'll have the magnetic as well as the coils will be there. So once the coil cuts the magnetic flux, the electricity is produced. Most of the grid connected wind turbine uses asynchronous induction generators, but having disadvantage that it will draw reactive power from the grid system. So if it is directly grid connected means നമ്മൾ പ്രൊഡ്യൂസ് ചെയ്യുന്ന പവർ ഡയറക്റ്റായിട്ട് സപ്ലൈ ലൈനിലേക്ക് കൊടുക്കുക. നമ്മുടെ വീട്ടിലേക്കൊക്കെ വരുന്ന ലൈൻസിൽ അതിലേക്ക് ഡയറക്റ്റ് കൊടുക്കുന്നതിനാണ് ഗ്രിഡ് കണക്റ്റഡ് എന്ന് പറയുന്നത്. അപ്പോൾ മോസ്റ്റ് ഓഫ് ദി ഗ്രിഡ് കണക്റ്റഡ് വിൻഡ് ടർബൈൻ യൂസസ് asynchronous or induction generators. That types of generators are usually used, but having disadvantage that it will draw reactive power from the grid system. ഇതിൻ്റെ ബുദ്ധിമുട്ടെന്ന് വെച്ചാൽ ചില സമയത്ത് ലൈനിൽ നിന്നുള്ള പവർ ഇങ്ങോട്ടേക്ക് അത് വലിച്ചെടുക്കും. കൃത്യമായി പ്രോപ്പറായിട്ട് ഇവിടെ പവർ പ്രൊഡക്ഷൻ നടക്കുന്നില്ലെങ്കിൽ ലൈനിൽ നിന്ന് ഇങ്ങോട്ടേക്ക് പവർ വലിച്ചെടുക്കും. അതാണ് പ്രശ്നം. Synchronous generators do not require reactive power, hence are used by the utilities. For small scale purposes, usually we will be using synchronous generators, and the synchronous generators will not have such difficulties. It do not require reactive power. Okay. Now the important component of the wind turbine is, actually it is not a component we can say, but still this is the controlling mechanism we can say. Yaw control system. It is used to continuously orient rotor to the wind direction. As I have already told, the direction of the wind will be changing from time to time. It can blow from any direction. So based on from which direction wind is blowing, the rotor of the wind turbine has to be kept in align with that direction of the flow of the wind, or it should be always facing the wind direction. So that is what is done by this yaw control system. So using this some sensors fitted into the anemometer, we will be sensing from which direction wind is blowing. Based on that, some electronics components will be there, which will be rotating that upper part, okay, along with nacelle and rotor. The entire upper part, which is kept as horizontal, you can see this entire part will be rotating in 360 degree, so that always the hub and rotor, this hub and blade, this rotor will be always facing towards the wind. The mechanism which is doing that is what is known as yaw control system. Use it to continuously orient rotor to the wind direction. It is done by using a rotary actuator attached to the gear ring at the top of the wind tower. A slow closed loop control system is used to control the yaw drives. Okay, that's all about the components of the wind turbine. Now these are all not important components, but still we can consider it as component, that is storage and energy converters. So whatever energy is produced, either it will be directly connected to the grid, or otherwise we will have to store it. So for storing purposes we must require the batteries and all. Most common storage system is lead acid battery. Usually the electricity produced is DC, so if you want to convert it into AC current, then alternators will be using the alternators. So this storage, energy storage or batteries are usually kept at the bottom part of this tower. You can see some room like structure will be there at the bottom part. There we will have that arrangement for storing energy produced. So cables will be there from the upper part through this supporting structure or tower, and the current is finally stored at the lead acid battery kept at the bottom part. Okay, so the important one is, next component is tower. The tower of the wind turbine carries the nacelle and rotor. Towers may be made from steel or concrete. Usually steel is most commonly used. Range of the tower is from 12 to 37 meter for small application and 30 to 75 meter for high application. Now this is see, for high power production the height of the tower will be around 75 meter. That is a huge massive structure. You cannot even imagine that much huge structure it is. Okay, now based on the uh, direction of the wind and the rotor, how the rotor is placed, we will have two categories of the wind turbines, that is upwind machines and downwind machines. In upwind machines are those machines that have a rotor facing the wind. In these machines the wind meets the rotor first and then leaves from the direction and in which the nacelle is located. അപ്പോൾ ഈ അപ്വിൻ മെഷീൻസ് ആണെങ്കിൽ ഏറ്റവും ഫ്രണ്ടിൽ ഹബിലാണ് എന്ത് കണക്ട് ചെയ്തിട്ടുള്ളത്, റോട്ടർ കണക്ട് അല്ലെങ്കിൽ ബ്ലേഡ്സ് കണക്ട് ഇല്ല. ആ എൻ്റയർ സ്ട്രക്ചർ റോട്ടറാണ്. ആദ്യം വിൻഡ് വന്നിട്ട് റോട്ടറിലാണ് സ്ട്രൈക്ക് ചെയ്യുക, എന്നിട്ട് ബ്ലേഡിനെ റൊട്ടേറ്റ് ചെയ്യും, അപ്പോൾ ഹബ് റൊട്ടേറ്റ് ചെയ്യും. അതിൻ്റെ പുറകിലാണ് എന്തുണ്ടാവുക, നാസല ഉണ്ടാവുക. നേരെ കുറച്ച് ഡൗൺ വിൻഡ് മെഷീൻസ് ആണെങ്കിൽ കാറ്റ് വരുന്നത് നാസലൻ്റെ ഭാഗത്തു നിന്നായിരിക്കും. നാസലനെയും കടന്നു വന്നിട്ടാണ് എവിടെ സ്ട്രൈക്ക് ചെയ്യുക, റോട്ടറിൽ സ്ട്രൈക്ക് ചെയ്യുക. ഓക്കെ, ദാറ്റ് ഈസ് ദ ഡിഫറൻസ് ബിറ്റ്വീൻ അപ്പ് വിൻഡ് മെഷീൻ ആൻഡ് ഡൗൺ വിൻഡ് മെഷീൻ. അതായത് ചുരുക്കി പറയുകയാണെങ്കിൽ ഈ ഫിഗർ വെച്ചിട്ട് വിൻഡ് ഇവിടുന്ന് വന്നിട്ട് ബ്ലേഡിൽ സ്ട്രൈക്ക് ചെയ്ത് ബ്ലേഡിനെ റൊട്ടേറ്റ് ചെയ്യുകയാണെങ്കിൽ അതിന് ഡൗൺ വിൻഡ് മെഷീൻ എന്ന് പറയും, അല്ലെങ്കിൽ ഡൗൺ വിൻഡ് ടർബൈൻ എന്ന് പറയും. നേരെ മറിച്ച് വിൻഡ് ഈ ഭാഗത്തു നിന്നാണ് വരുന്നതെങ്കിൽ ഡയറക്റ്റ് എന്താണ്, ഫസ്റ്റ് ബ്ലേഡിലാണ് സ്ട്രൈക്ക് ചെയ്യുക, എന്നിട്ട് റോട്ടറിൽ സ്ട്രൈക്ക് ചെയ്തിട്ട് ഇത് റൊട്ടേറ്റ് ചെയ്തതിന് ശേഷം അതിനുശേഷമാണ് വിൻഡ് നാസലെ കടന്നു പോകുക. ഓക്കെ, രണ്ട് തരത്തിലാണെങ്കിൽ നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റും, പവർ പ്രൊഡക്ഷൻ പോസിബിളാണ്. പക്ഷേ രണ്ട് കേസിലാണെങ്കിലും ഹബ്ബ് എപ്പോഴും എന്തായിരിക്കണം, വിൻഡിൻ്റെ ഡയറക്ഷൻ. വിൻഡ് ഇപ്പോൾ ഇങ്ങനെ ഇങ്ങോട്ടേക്കാണെങ്കിൽ ഹബ്ബ് എന്തായിരിക്കണം, വിൻഡിന് പാരലായിട്ട് ഉണ്ടായിരിക്കണം. അതുപോലെ ഇങ്ങനെ ഇങ്ങോട്ടേക്കാണെങ്കിൽ ഹബ്ബ് എന്തായിരിക്കണം, വിൻഡിന് പാരലായിട്ട്. എപ്പോഴും വിൻഡിനെ ഫേസ് ചെയ്തെന്ന് പറയാൻ പറ്റില്ല, ആക്ച്വലി പാരലൽ ടു ദ വിൻഡ് ഡയറക്ഷൻ, അങ്ങനെ ആയിരിക്കണം. ഓക്കെ, so based on that two classifications there, upwind machines and downwind machines. Okay, now that's all about the construction and components of the wind turbine. Thank you.